everyone. Have you ever wondered why microcontrollers seem to be so complex, even to someone who's already been developing desktop applications? Well, they're complex for a reason. They're actually complex because they're as simple as they can be for the tasks that they were designed for. And it's just that what makes them look complex in comparison to the pampering abstractions we indulge ourselves in the PC world. And making them more complex would just make them less suitable for the tasks that they were designed for. Because writing to an obscure register will just be more energy and time efficient over parsing some JSON file each and every time. Let me explain what I mean with a comparison. We'll see the difference between writing to a serial port on a PC and on an Arduino Uno.
Okay, let's check out the desktop application first. This is a bare minimum example of how to transmit and send data over a serial port in Python. Obviously, this is not production code. There's no error checking, no try except blocks. It's just the bare minimum to transmit and receive data. Basically, all you have to do is prepare the serial, define the serial port, prepare the data to be sent, write the data, read the data with the prepared timeout, and print out the received data. Let's see how it works. It sends out a ping and receives a pong from the other side. Now let's check out what's on the other side. On the other side we have an Arduino program which is quite similar. We have a serial port, a definition of a serial port with a timeout set to wait for characters. We read the bytes, we read 4 bytes. We change the byte on position 1 from I to O, so we get a pong from a ping, and we transmit the data.
But wait a minute, I was trying to make a case about how difficult programming microcontroller is. And now it seems that this Arduino program, it looks even simpler than the Python one. What's the deal here? Well, this is the genius of the Arduino language, let's say, in my opinion. They've managed to really lower the bar for someone who's entering in the world of microcontrollers, and they're just making it really easy to start programming without knowing all the nasty details. But of course, this approach comes with a cost. The simplicity comes with a cost. And the cost is that with time, you're not exploiting the full potential of the microcontroller. It's a bit like riding a bike with training wheels without really being aware that you're riding a bike with them, and thus missing the whole potential of your bike, sort of. Now let's take a step forward and see what's happening under the hood, and in which cases would anyone even want to look there.
The easiest way to learn what's going on under the hood is to check this compilation and upload information in the Arduino IDE, and noticing that instead of our serial.ino file that you've placed in your project file, what's actually being compiled is a serial.ino.cpp that's been placed under application data on your user directory, at least on Windows. And if you go and look into this file, I've already looked for it, so I don't have to meander through the file system. You see that it's quite similar to the original file. It just has some preprocessor directives that are not actually interesting in this context. But there's an arduino.h include file at the beginning, and this is where the fun starts. Now we could go and look for this arduino.h on our system, but I think it's going to be easier just to browse through the repository, the Arduino repository. If you go under AVR, course Arduino, you find the Arduino.h right away, and this is the same Arduino.h that's been included and compiled in your project. Now let's look inside. The first four includes we can view them as some helper functions provided by the standard library or utilities to work with strings or mathematical functions. But the next three are tightly related to hardware. And let's just look at the io.h to make a point, to make an example. The io.h cannot actually be found in the Arduino folder because it belongs to another project called AVR libs. And in that repository, if we open the io.h, we can see that it's full of conditional includes. And it depends on the actual microcontroller which concrete file will be included. And in our case, it will be the atmega 328p. And if we open this file, now in here, we can see that there are a lot of definitions and macro definitions tightly related to the hardware underneath. Now let's do some seemingly random cherry picking and look at this or this definition. Now this is actually a register in the Arduino microcontroller. And this is a macro. It is actually a function used to write into this register. And so what are actually registers? Well, registers are just memory locations to which we write or read from, and they define the behavior of some aspect of the microcontroller. In this case, we're talking about the baud rate of the microcontroller. This is where the 9600 bauds are defined. If we write a number to this register, it will define the baud rate of the UART communication. Of course, we cannot write the baud number directly. That would be too easy. And it's also dependent on the oscillator that we are using, the quartz crystal. But it's not too difficult. There's an equation somewhere that defines the baud rate that's dependent on the oscillator that we're using and the actual number written in the register. So when we write to this register, we define the communication rate or the baud rate of the Arduino program. Congratulations for making it this far. You've taken a dive from a console application that uses an OS, that uses drivers, to a bare metal solution where the application, the OS, and the drivers are one and the same. Well done. Why have I mentioned the baud rate register? Well, it's because you use it when you call the hardware serial begin function, and that's where you specify the 9600 baud rate that we saw earlier. And this library is under Arduino core, Arduino hardware serial.cpp, and it uses this baud rate to calculate the baud rate setting according to the equation that we just by accident saw in the user manual of the atmega 328p chip, aka Arduino. And when it calculates this baud rate, it writes it into this register. But where is this register defined? That variable is defined through constructing the hardware serial object using information provided by the io.h include file that we saw earlier. So that's the connection between the io.h file and this hardware serial library. Well, a sane person might ask, why would anyone even bother with such details if everything can be accessed by the high-level functions? like the ones we just saw for the serial port? Well, it turns out that everything cannot be accessed by the high-level functions. For instance, say that you want to be really precise at printing out through the serial port some information every 10 milliseconds. There is just no framework in the Arduino language to do that. You have just a few time functions available, and probably the delays are precise, but maybe you would like to do something with something useful in between. So in that case, you would need to use timer interrupts that are not covered with the Arduino language. And how would that look? Well, say that you want to print Pong every second or do something equally important, but you're blocked with printing ping every 2 seconds. Here I'm using a delay, but it could be some other blocking function. Well, in that case, knowing that a timer exists and that can be used with interrupts is very useful. You just have to know how to set it up. In the Arduino case, we set up timer 1 by first modifying one register that puts it into normal mode, which just means that it's not toggling any pins. It's just being used as a counter with interrupts. We set the prescaler of the timer, which means how fast is it increasing its value. And then we set a threshold, a value at which it will trigger an interrupt. And of course, we have to enable the interrupt. And then every time the condition is met, the interrupt vector, which is a special function, is called, and it prints Pong. And I argue that there is no way to do it with just by using the Arduino language. Actually, the delay function works in a similar way. It also uses interrupts. It just uses another timer.
Well, I hope you liked this deep dive into microcontroller programming. I would just like to add that Arduino is not the only board producer that's been using this approach. Also, bigger players are using it, and in many cases have even shifted in hardware towards Arduino just because it makes programming so accessible. But depending on the problem, it can be a blessing or a curse.